My name is Petr Ferschmann. I'm a co-founder of FlexiBee accounting software, which I sold, and I'm working on Dativery and FNX. FNX is a company for backends, and this is the reason I'm here. Today, we will talk about two topics. The first one is why you should think about platform as a service, and especially about Lambda, and the second is about Lambdas. As told, I'm co-organizing Backendisti, but I'm also making video podcasts for developers, Cafe Mlejnek TV. So if you want to see something, you can watch there. And if you have some tips about guests, let us know. It's fun to do that. So let's start. This is the classical architecture, three-layer architecture. We have client, or in this case, browser, application server, and this is SQL server. The first things you will think of is how to scale it. So you will end up with something like this. You have more application servers and one load balancer that scales the requests between the requests, the application servers. So classic. But usually we are lying to ourselves that it will not fail. And when we start to create the platform more reliable, we will end, for example, with something like this. This is schema of FlexiBee. How is it done? We have multiple load balancers. Usually we are using round-robin in DNS, and we have multiple application servers, and we have multiple clusters of databases, where is one master and second slave, usually. This is classical architecture, and the client can end anywhere, so it will be handled there. So, but this starts to be quite complex and hard to create. So, usually in the past, we used to do this the way that we have operations or administrators who were taking care of such configuration, and developers who just develop the software, give it to the administrator, and he run it. It was bad because the administrator can't fix the code and the developers didn't care about the code. So we ended with DevOps. Who of you is doing DevOps? Raise your hand. And what the rest? The idea is that developers take care about the platform, how is it run. It's because today we usually have only one installation, one production installation. In the past there were multiple, today we have only one, and it's a good idea for developers to take care of them. Operations usually help them, but the developers maintain the system. The good thing is that they can fix all the problems. They can install all right code that help them debug in production. They fix some troubles to make it run smoothly. Usually in the past, for example, we used to reboot or restart, for example, SQL database every night to be sure that it's ready. But developers don't like this, so they will fix the root of the problem. But problem is that developers are expensive. There are less and less of them. You can't find a new one, or it's hard. And they actually like to develop and not to maintain the system. So it costs a lot of money. And the question is how to decrease the costs of servers and operations and so on. Because it needs the best people in your company. Usually the best developers are maintaining the system. They are fixing the problems. And the problems are usually when you don't expect them. For example, we were on a mountain and we were fixing problems from there. So only phone and no internet. So it wasn't easy, but it had to be done this way. And salaries are growing. They are very, very high today. And they are the same nearly in the whole world. For example, I heard about some guys from Palestine, and they were paid the same amount like in Pilsen. So it's not that you can outsource it and make it cheaper. So this is not solution. And as I said, developers don't like it. So what is the solution? How to fix this problem? Solution number one, ignore. This is good one, especially, because it's not bad to ignore the complexity of the architecture and just allow platform to fail. Sometimes it's not bad if it fails once a year in the night. It can be cheap and not a problem. So you can ignore the problem, or you can ignore some parts of the problem. For example, who of you have high availability solution? Your application has some sorts of high availability. Raise your hand. Yeah. Who of you have tested failover to slave? And who of you have tested failure back? Or fix back? The thing is that very few of us really does that, and it's not bad. Just ignore it, and you can make the things that your clients want. So solution number one, it's not funny, it's real. And the second one, which I would like to offer you, is to use platform as a service. The idea is that if you make your provider if you allow them to run your application, you have less work to do. For example, in the case of FlexiBee, we paid about 50,000 crowns every month for cluster, and we paid the same amount for a developer who was taking care of it. Sometimes it was half of his payment, sometimes the whole payment, his whole job was to fix it. So if we allow the platform to do that, it can get easier. So what parts of platform we can use? I have there virtualized servers. It's not really platform, it's infrastructure, but it's there for completeness because sometimes it's good to use them. Of course, function as a service, it will be in the second part. Store, this means blobs. Do you know what's the difference between block storage and blob storage? For example, blobs, the thing is that you lose some flexibility, and back you get more performance or more scalability. So in the blob store, you can't change the file. You can't modify him. You can't seek and find something in him. You can only download the whole file. And the good thing is that it's easy to scale that, and it's easy to have backups or slaves that can take over the primary source. So, for example, in S3, you have when you are using blob storage like S3, it's very easy to use and it's very, very scalable. CDN, Content Delivery Network. Good thing about Content Delivery Network is the primary idea is that you have many edge or many servers in many locations in the world, and you provide the data closer to the client. So, for example, in Prague we have CloudFront. It's a CDN from AWS, and so you don't have to download data from Frankfurt or USA or something like that. The good thing is that CDN is sometimes good, even in the case that you are not caching anything. The thing is that if the client makes a request, for example, types something in browser, you have to do DNS lookup, you have to establish the connection, you have to do, for example, redirect from HTTP to HTTPS, you have to establish the secure connection, you have to verify that the certificate is valid, it's not invalid, and so on. And it takes many roundups. What happened? Monitor is broken. Já nevím. Jsem zkoušel. No signal. So if you are using the CDN, even in the case that you cache nothing, you just connect to the backend server. The connection, the establishment of the connection is much faster because it's closer to the client. And usually the connection from the CDN to the backend server can be already established. And so it's faster even in the case you are not caching because of the roundups. So that's CDN. Yeah, I can see what I have there. I can describe you what is there, and you can imagine it. So, managed database. Usually, maintaining a database takes a lot of effort. So, if you use managed, something changed. Okay. It's a quiz. Who takes A3? Okay. So managed database ideal. It's either SQL or no SQL. In case of Amazon, it's RDS. That's SQL. And for example, DynamoDB. That's no SQL for Amazon. Load balancers, maintaining load balancers and solving all the failovers and all the scaling of the load balancer. It takes some time. If you use service provided by your provider, it can be easier. AI, but it's not important in this case. So the basic idea is that platform as a service converts not all of your problems, but a lot of your problems to money. So when you are using, for example, AWS, and you have to solve something, you start what do they offer. Usually they are paid not by in front, but you pay by using the service. So in the beginning, it's very cheap. And if for you it starts to be expensive, you can always rework that part and use another solution, not, for example, provided by your provider. So, for example, if you need push notifications, you can, you know, push notifications, it's like Firebase when you need to notify all your clients that something happened. You can develop it yourself. And when you start to get, for example, 1 million of connections, it takes a lot of development to maintain the cluster that handles the connection. If you have 1 million connection, it's a lot of connections, and you have to take care about reconnecting and providing the data to the client. If you use, for example, AWS and their SNS, simple notification services with IoT, I don't know why they call it IoT, but it's exactly the push notifications. So the browser subscribes to topic, to IoT, and you can send it from the server side to the client, and you don't take care how is it delivered. It's already developed, and you don't take care about anything. And that's what they are doing. And if it's expensive for you, you can always develop your own solution. But you start with what they provide. So platform converts everything to money. So there are a lot of things why the platform can be cheaper, for example, than your own servers. If you have your own servers, you have to buy them in front. In platform, you can scale your environment down, for example, in the night, or you can have very cheap staging or development environment where developers have the same environment like is in production. This is, for example, what we are doing in Dativery. Every developer has completely same cluster. It's not good to call it cluster, but environment like is in production. But it's scaled down, and the scale is done automatically, so you don't have to take care about that. So the first thing is convert your application to AWS. I have there one use case about not our customer, but customer of my friend, that has one server that costed about 100,000 crowns, and they expect it to lifetime 4 years. It's one server with 8 CPUs, 64 gigabytes, and they pay housing 2,000 crowns every month. That's quite cheap. And the maintenance costs about 10,000 crowns every month. So together with server, with housing, with everything, it costs about 15,000 crowns. This service is quite popular. I think you know them, but I can't name them. They have 65,000 visits every month, 8 million requests every month, and 8 terabytes of traffic. They have database have 8 gigabytes, and 800 gigabytes is static contents, and the peak is about 300 requests per second. So it's very used service. They don't have high availability. They are ignoring the problem, and the server is very reliable, so they have, for example, maintenance every 1 year, so they don't have to take care of that. There is not backup, because backup is done on another server that is used for another service, so it's nearly free. We wanted to translate them to AWS, and this is what we get. We transferred it, no, this is the plan, it's not the result yet. So we transferred it to Lambdas. So the Lambda in all these requests will cost $17 per request, for a request, and $35 for traffic. The database that is managed costs about $100 every month, so that's cheap. It's not in high availability. In case of the RDS, it costs 30% more than classical virtual environment EC2. The good thing is that if you want it to high availability, you pay twice that amount, $200, and you have 2 servers. Do you know what is the difference between region and availability zone in AWS? Who knows that? Who doesn't know that? Who sleeps? Amazon have multiple regions. One is in Frankfurt, Dublin, now in London, US. There are, I think, 15 regions. Every region have multiple availability zones. One availability zone is a server house, server room, I don't know, that have completely separate everything. Separate electricity, separate internet connections, separate rooms, separate cooling, and so on. And they are completely separated. So usually only one server room should fail, not both. If you blast them with nuclear weapon, they will be both destroyed, of course. So this is availability zone. The RDS of MySQL, if you click something, checkbox, it will be run in 2 separate houses in a separate availability zone, and you don't have to take care of that. And if one of them fail, it will fail over to another one. But I think in this case, it's not necessary, because the managed service is run over EBS, Elastic Block Storage. That's a network hard drive in Amazon. It's a RAID-like service that is distributed between many servers. So if you write something, it's written on multiple servers. So if you fail, if one of the hard drives fails, it's completely replaced, and you don't have to take care of that. And good thing is that, for example, if the server where the MySQL is running fails, it can be stopped and started again, and it will run on different server from the same storage. So if you reboot and failure, for example, of 1 minute is not problem for you, you don't have to do multi-AZ. You just use the service in one availability zone, and you pay that money. So it's cheap, and you get the short outage out of the price. It's not that you have to switch something to different server. It's just rebooted and running on completely different server. So it was quite cheap comparing the current costs, what wasn't cheap was traffic. AWS have very expensive traffic. That's bad, but it's true. So in this case, it would cost $600. If you switch to CDN 77, for example, it would cost half, $300. And the storage, it's quite cheap. So if you switch this service that currently costs 15,000 crowns to AWS, it should cost about 25,000 crowns. It's more. It usually is twice as much as before, but you don't have to take care of the maintenance. For example, the MySQL is upgraded for you. You just say, I want it upgraded in the midnight and on Sunday, where your traffic is low, and they will upgrade it for you. They will make backups for you. They are making backups of snapshots of the hard drive. So if you need a copy for you, usually you have to copy the complete drive. And this means that if you want to do it in production, it means that you lower the performance because you are reading everything. But in the case of EBS, the blocks, the backups are only difference between the previous night. And if you want to make a new server that has completely same data, it doesn't have performance penalty on the production. You just click and you will start another SQL server with the same storage. Good thing about EBSC is that if you start a new system from the image, it's copied as you request it. So it's available right now, and the storage is copied in the background. So it just works from the first beginning. So this is AWS. Usually it's twice as much as classical solution. I wanted to explain you more. This is the red line is service requirements about servers, and the green one is server you have. For example, from the beginning you have one server, and the idea is that when you need more, you buy more servers. So in this case, during these years, you will have 89 server months. But this is not true, because this is bad, because in this case, if you lose one server and you want backup, it means that you don't have enough power to run your service. So it has to look like this. You have to have always at least one server that is not utilized to run your service, to be able to one of them fail. So in reality, it's 115. But if you have something that can grow with your needs, for example, in AWS, it's 68. So usually, if you are using virtual server from AWS, it costs twice as much as when you have your own server. But you have to compare those two numbers, and that means that it can cost twice as much and cost you the same amount. The good thing is that if you have, for example, 2 weeks or 3 weeks before you get your server delivered, in this case you can be lost because the requirements are faster. And in this case, you always have your requested servers. So that's a simple comparison. If you have any questions, just ask. It's not. Yeah. So, what is it function as a service? As I said, in the case of the S3, if you lose some of your possibilities, you can get something back. And that's the same thing like in function as a service. In the regular case, for example, if you are using application server for Java, Tomcat, or something like that, JBoss, you usually run everything inside. In case of function, you create code that handles only one client, one request, not multiple of them, just one, and it's stateless. So when the request is finished, the function is lost. It's stateless and nothing is there. And thanks to these things, the complete maintenance of this function is done by the provider. You don't take care how many servers will handle it. Everything is handled by the provider. So, short comparison, I have virtual server, I have container like Docker, and function as a service. In virtual, I have to take care about operating system, I have local storage, it's not stateless, and usually the virtual server runs very long time, for a very long time. It's more than a year, 2 years, or something like that. In the past, I was said that average mean time of failure in AWS is 1 year, but my experience is that it's much longer. Sometimes the virtual server will reboot or get lost. Reboot is get lost, but usually it's longer than a year. If you want to autoscale it, you have to do it usually manually, or you can use autoscale or something like that, but it's slow. It takes some time for the server to be ready. So it usually takes minutes, sometimes even an hour or something like that. If the memory is shared between instance, so if one request needs much more memory, it takes the memory from other requests. And if something fails, the complete instance fails, and all the handled requests, not only the requests that failed, but all of them. For example, in Java, garbage collector starts to run and it's lost. In container, you don't have to take care about operating system. The runtime is usually long too, but not that long. Autoscaling is usually included, and scaling then takes about tens of seconds, sometime less, sometime more. And memory is still per instance, and failure again per instance. In function as a service, you don't take care about operating system, local storage. It's stateless. The runtime is very short. For example, AWS Lambdas have limit about 5 minutes. You can't run Lambda for longer than 5 minutes. After 5 minutes, it gets closed, and the request is error. This autoscaling is very quick, and you don't take care of that. It's just there. And memory is per request, and if something fails, it's the request that failed. So, yeah. The providers of functions as a service, there is Amazon, Google Cloud Platform, Bluemix, Microsoft Azure. Sometimes somebody says that Heroku is a function or has function as a service too. I don't know. So what is it Lambda? It's nothing special. This is Node.js, and it's a function that gets called, and this handles HTTP requests and return JSON that returns this. You can set HTTP headers, status code, that's all. Nothing else. It's just this. It's very easy. Of course, you can write the code in Java, Node.js, everything you want, and you don't take care of anything. It's just for you done. You can understand that? It's very easy. It's nothing complex. Just a function that returns HTTP response.
What about node modules?
Yeah, I will talk about that later. You can use them, of course. The thing about Lambdas is that you don't, and when you have virtual server, you are paying for it even if you are not using it. In case of Lambda, you are paying for gigabyte seconds. So if you say this Lambda needs 500 megabytes of RAM, and it runs for 3 seconds or 200 milliseconds, you pay only for that. So if you handle 10,000 requests, it's not your problem if you don't take care about if it's run during 1 hour or during 1 month. You just pay for the requests and for the gigabyte seconds. So if you want to run something for 60 seconds, you can also run it 60 times for 1 second, and you pay the same amount. But for the user, it's different. Yeah, if it takes 60 seconds or 1 second, that's a big difference. Yeah. So You can usually Lambda can run. That will be later. HTTP requests, but there are more things you can run. So comparison. As I said, you are paying per gigabyte second. So this is the price. 1 gigabyte per second costs this. So if you want to run 60 seconds, 60 minutes, 24 hours, it takes $1.50. So Lambda, that will take one whole day, costs that. That can look a lot, but if we look, so this is how you pay per gigabyte seconds, and you get 400,000 gigabyte seconds for free. And it's a free tier code, and usually in AWS, free tier ends after 1 year, but Lambda is there for forever, the free tier. I know about one company that was running, when you uploaded image to S3, they needed to generate previews. And during half a year, they generated about 5 million previews, and they didn't pay anything for that. It was just there. So, so what can invoke Lambda? Usually it's HTTP requests. There is something called API Gateway that is part of AWS, and it transforms the request. This is how it's done. You can directly call it. For example, if you need microservice architecture, you can invoke Lambda, and you don't have to take care where is it run, how is it run, how often, and so on. You just call it. So, for example, discovery or something like that, you don't need that. You just invoke a Lambda. And the third one is platform event. For example, we have Lambda that scales DynamoDB database for us, and it's run every 2 minutes. So cron, for example. Or you can call Lambda when you upload something to S3, for example, image. So you will, when there is image, I want previews of that. So. Doesn't work again, but I'm clicking something wrong. The thing is that in Lambda, you have to write the code through the web interface, and that's very bad. So we are using serverless framework. It's a framework that you write everything in file, in Git, and you just call SLS deploy, and it uploads everything to AWS. It's using CloudFormation. Do you know what is CloudFormation? You don't? CloudFormation is a declarative configuration of AWS. If you tried AWS, it's very complex interface with all those regions. And if you create something in one region, it's not visible in another. And you can get lost. If you use CloudFormation, it's a template that it's uploaded and it creates everything. So you can have network as a software, you can configure everything, and you can configure servers, everything can be done through the CloudFormation. This is what we are using. So serverless is a great framework. There are others, but the serverless is today, I think, the most complex, or not complex, with most features. So, small comparison of EC2, so virtual server, and Lambda. In case of small web, where you have 10,000 requests per day, a request takes 200 milliseconds, 256 memory, and it means that you have 332,000 requests per month. That's that amount of gigabyte seconds, and this is the price. Yeah, but this is not true really, because everything, this is for free. So when you eat all your free tier, it will cost that. But in the beginning, it's for free. Another example, cron that is run every hour, needs 1 gigabyte of RAM for 2 minutes, $2, $1.50. So, this is comparison of when you take when you take cost of EC2 and compare it with Lambda, this is the comparison how much requests you have to do to compare the price. And this case means that you have to handle 80 requests per second. But you know, one virtual server with few memory doesn't, it's not able usually to handle that much of requests that in average. But in the peak, there is a lot of much more. But in the case of Lambda, you don't care. It's just there, you pay what you handled. Yeah, so this is the comparison. And the most interesting part, technical details. What is it exactly Lambda? Before we start, what languages you can use? Today, the Node.js is supported. I think they now announced 6.1 version. You can use Python, Java, and C#. In reality, you can imagine it like a Docker image. When you create Lambda, it's a zip that you upload to S3, and the environment of Lambda, when you invoke the Lambda, it's never deployed, never anywhere deployed. So it decide that it will deploy it on one server. They download the S3, the zip from S3, unpack it, and create something like Docker environment where it runs your Lambda. Because it's Docker environment in Linux, there can be run anything. Currently, they support these languages, but you can do anything there. For example, you can create module for Node, and you can invoke anything binary, anything you want. So it's a Docker, or it's something like Docker. There is a limit that you specify. When you create a Lambda, you say how much memory the Lambda needs, and it can't get more memory. And everything in that virtual container and Docker is counted as a consumed memory. So you can run, I don't know, any PHP or something like that. The amount of CPU you get depends on how much memory you provide. So if you have something that takes 3 seconds and needs 256 megabytes of memory, if you provide it twice as much memory, it will get twice as much CPU performance. So usually it means that it will take half of that time in this case. So sometimes it's better to give more memory. You will get the request sooner, but the price is same. Yeah, of course, if you are making network requests, it's not ideal because you are waiting or something else, so more CPU power will not help you. I said that Lambda is completely stateless. It's not exactly true because if the Lambda starts, there is a static initialization, and then the request is handled. The request runs, and when it ends, and say this request is handled, the complete container gets freezed. So it will stop getting CPU, but it's still there, prepared. So if another requests come, it's unfreezed and handled, and then again freezed. And if the Lambda is not used for 10 minutes, it gets destroyed. So what does this mean? Lambda handles only one request. So you can say that it's one thread, but you can invoke background threads. But they will run only during handling the requests. When the request is finished, it freezes and waits. Sometimes there is another invoke, so it gets again unfreezed. But if it's destroyed, nothing happens. This is usually hard for example, connection pooling in database, because there you say, okay, after 2 minutes, I want the connection to release. But the container gets freezed, so it will never get again woken. But you can store environments statically, for example, in your environment, or because it's virtual container, you can store data on the local storage. But you can't be sure that it will be there next time. So you can cache data locally or generate temporary file, but you can't rely on that. Performance memory. I say there is 5-minute limits. That is the maximum Lambda can run. You specify the limit, so you can say, for example, this Lambda can run for 5 seconds, and after that it's destroyed. If you make the request, and there is no Lambda handling it, it gets queued in the queue and waiting for Lambda to be prepared to handle it. And if there is not enough Lambdas, more and more Lambdas will start. So, for example, if you have, in our case, the zip of the Lambda have, for example, 20 megabytes of packed. And when we want it unpacked, it takes 2 or 3 seconds. So, new first request take 3 seconds more than the others' request. So, for example, a lot of people is doing that they are making empty requests every 10 minutes to be sure that the Lambda is prepared. This also means that if you make, for example, advertisements and hundreds, thousands of people comes to your service at once, it will take some time to start all the Lambdas for you. So sometimes it's better to contact AWS support and say them, I want to hit more Lambdas, and they will prepare more and more for you. It usually doesn't cost anything, so you just ask them. So there is also a limit from the beginning on how much Lambdas there can be in parallel. For example, I was on a hackathon, and there was a lot of money in credit, and I wanted to eat all of them. So I created a service that called Lambda, and this Lambda called 10 Lambdas, and every Lambda ran 10 Lambdas, and then I reached the limit, and that was good, because otherwise I would eat all the services, all the performance they had, because it's exponential growth. The funny thing about this is that I ran it for some time. It was actually doing something. It wasn't just empty invokes, and I wanted to consume all the money, because it was a lot of, and I wanted to create a so scalable service that it costs hundreds of thousand crowns. And after 10 or 20 minutes of running that, I asked myself, is it their credit card or mine? And what do you guess? It was mine credit card. So, my credit card gets eaten. But so I checked, and we switched to their credit card, and it costed me $5, so it wasn't that bad. And it's because of the free tier. Don't forget. So, this is versioning. When you create new Lambda, you upload it as a new version, and the switch is with no fail. It just gets switched. You can even switch back. It's very easy with Lambda to maintain the versions. So this is Lambdas. I don't know how much time. I have some time yet. So another interesting thing is authorizer. Security is important. So API Gateway have support for authorizer. It's Lambda that it's called before the actual Lambda that handles the request. And you specify what is the key for the authorizer. Usually it's cookie or it's header, for example, authorization HTTP header. And the Lambda validates that value. For example, it can read from database that the password is correct. And then or session cookie or something like that is correct. And then it returns it's okay or it's bad. And the Lambda allows, or API Gateway allows to cache the result. So next time, it will cache the result. For example, session identifier. So it will be faster, and you don't have to check user every time, because usually you have to check against the primary database, and it consumes a lot of money. So authorizer is a good thing for AWS. In our case of Dativery, we are using Auth0 service. it's a service for authorization, and they are handling all the DDoS, all the attempts to break passwords, and so on. And you just show user interface in JavaScript for the user, and he logs, and then you get JSON web token. That's a string that's completely stateless. So you have a shared secret between the service of Auth0 and your service, and it generates a token with some time of validity, and you can use it. And it's completely stateless, so you don't need session or something like that at all. Usually session is very badly scaling because you have to have some sort of cache that is everywhere to use the session. But in this case, you can get rid of that. Usually when you have a single page application, you don't need to store anything on the server because everything is in the client. So this is authorizer. Questions? So the last is security. What I like about AWS most is security. It's because imagine a system where you can create layers of security and be sure that it's hard to break from one layer to another layer. Who of you is using AWS? Yeah. And how many accounts do you use? One? Root account or more? Who is using more than one? Yeah, that much? Yeah, sorry. So AWS is allowing to use multiple accounts. For example, in our case, in Dativery, Dativery is a service that stores passwords of client and to make API requests to their services and download the data. So passwords are very sensitive. So we created separate account in AWS that's completely separated, and we uploaded Lambda function microservice that's called, in our case, SafeStore. And it's storing the passwords, encrypted and so on. But if you want to read the password, you have to call this service from another AWS account, and it logs the request to, for example, S3 in our case. So if somebody wants to steal password, they can't select everything from database of passwords. They have to request every password separately, and there will be trail of that. There will be audit what happened, why they read it, when. So, and you can make some checks that if somebody is requesting too much password, it can notify you. And the good thing is that it's a completely separate service from the rest, because in our case, it's very important for developers to have full access to production, to solve all the problems. But if they have full access to the production, it's hard to disable them to steal the password. So it's completely separate service that can be invoked, but only by definite way, and they can't access this service. And you can make, for example, that only the director have the permission to deploy new version. So he will be sure that nobody can steal the passwords, because there is no way to access it, and only, for example, board or 3 members of the board are able to deploy new version. So developers deploy new version, and they make the permission, give the permission to do that. And that's something that is very hard to do on your own servers. And it's very easy with AWS. You can separate it this way. So, for example, in our case, we have multiple accounts. We have one account for SafeStore, one account for auditing or logging of other accounts. For example, if the developer makes some change, the AWS platform logs it to account that is not accessible for the developer. So he can't remove the logs what he changed. And there is another account for consolidated billing that is paying for all the accounts. And then there is an account for every stage. So if developer comes to our company, we create new account for him, and he gets unlimited access to this account. And he can do anything he wants, and he is developing against this account. It's like root password, and he's not limited by what is allowed to him, and he have complete copy of the production environment. Of course, it's downscaled. Usually Lambda is paid by requests, Dynamo can grow, so it's completely same, but smaller. So, separate accounts is a great thing, and if you are not using them, consider it. Audit logs. If you change something in AWS, it can log. If you access something in S3, it again logs. So you can make audits that are out of the control of the developer. And of course, there is a shared security responsibility of AWS, where there are parts that AWS takes care and parts that you have to take care of them. And for example, if you are forced to have some security certification, for example, in case of FlexiBee is an accounting software, and we had one customer that was working for Army, and their accounting was secret, I don't know, and they needed for us to have a certification, but we wasn't on AWS, and that meant that we have to certify the whole cluster, whole environment, and that was very expensive. But in case of AWS, we just inherit a lot of certification, or you have to just, for example, click that all data at rest has to be encrypted, but it's very easy to do that. So security in AWS is much higher than in classical environment, and it allows things you are not allowed possible in out world. I talked to one guy who was doing the support in AWS, and he was saying that they saw the metadata of the customer. They saw how many virtual servers they have, which services they are using, but they can't access the data. And for example, he said that they never saw the actual servers, and they actually didn't know where they were. It was just for them. They see photo of server, and they were told that that's their servers. So this is security, and that's all from me. So questions? No questions? Is it fast enough to serve web traffic? Yes, we are using it for web traffic. The slow thing is the deployment of your Lambda. So it's important to keep your Lambda smaller than in the classical way. And I think it's slightly slower than if you have virtual server without any load balancing, without any anything or any intermediate service, it's faster. But Lambdas are fast enough. Of course, today the most slowest thing is latency. It's the biggest problem, and that's usually the connection between the client and the server. And if you are using the modern single-page applications, if you are using, for example, GraphQL instead of REST for your application, it's not a problem. For example, in AWS, we measured that latency between two servers, it's half millisecond, 0.5 milliseconds. And that means that, of course, Amazon is much slower than your own server. Because if you make a request, for example, in Lambda, it means that you make connection to either CloudFront or the CDN or the API gateway. Then from there, it gets to the Lambda. Lambda reads data from database, so it goes to the database, and database reads the data from Elastic Block Storage, EBS. And this is all the servers. So something who took in the past microseconds now takes milliseconds, because the SQL requests have to go through the two servers, if not cached. So it's slower, but if you optimize it on the client level, because the slowest part is on the client's level, it's fast. I have a presentation on Backend this year about GraphQL. I have a speech called REST is Dead, long live to GraphQL. And if you are not using GraphQL today or something like that, you should consider it.
Do you use Lambda for something else than just JSON endpoint?
Yeah, we wanted to generate files, for example, zip. Lambda has binary support. The problem was that there is limit 6 megabytes. So we today, what we are doing is that the Lambda uploads a file to S3 and returns URL to the client.
And are you using something else for monitoring than CloudWatch?
Today only CloudWatch.
Even for logs?
For logs we are using it. Yeah, of course, for example, after 1 week, we move the CloudWatch to S3 because S3 is cheaper. As I said, in platform as a service, every problem is changed to money. And if it's okay in this case, you just pay. And if it's expensive for you, you can change it. What I said, for example, about the organizations, today there are a lot of services that you can buy managed for you, and they are running in AWS in the same region, in the same availability zone. So you just hire new, you just pay for the service, and they provide it to you in the same environment like you are running. For example, 2 days ago I was asked for how to run client's code in your environment. You get something from the client and you don't trust that. And one of the way is that the client create his own account in AWS, deploy his own Lambda, and you just invoke this Lambda. And the speed is completely same, like if it's your Lambda or their Lambda. And you just, in your application, you say, okay, I want to invoke Lambda from this account ID and with this name, and it invokes. So this is one of the way how to run code you don't trust.
Any other questions?
Have you tried the Azure Functions?
Not yet.
Are you willing to?
Oh, willing or planning? I'm willing, but not planning. In FNX, what we are doing, FNX is a backend studio. We are focusing on backends and cloud. And I'm AWS specialist, and my colleague Tomáš Zvěřina, he's Google developer expert. There are 4 in Czech Republic, and he's only one in Central Europe for Google Cloud Platform. So this is the 2 platforms we are using, and we think they are the best. Azure is good too, but Google Cloud and AWS is, I think, better. But it's just, feeling. And today, in the world of post-facts, the feelings are most important.
Somebody?
I have one thing about security. When we were doing FlexiB, we had one customer that don't trust internet banking. And we thought, yeah, he's old, he is old-fashioned. Who of you is using internet banking, and who don't? Is there anybody who doesn't use internet banking? On one presentation, I met one guy who was not using internet banking. I asked him how he's doing it, and then he said, "I don't have any money." And then this guy from this company, he was owner of a very large company with billion of crowns. Obrat, I don't know, every year, and he didn't trust that, and we say, oh, okay, he was old, so, but once he came to Africa, he went to Africa, and he got kidnapped, and if he had internet banking, he would pay ransom. Of course, who didn't? But the problem was that he would pay everything the company has. And it would mean that he lost everything, the company get lost, and so. And they were, of course, they had guns, and they wanted to shoot him. No, and because he was not able to pay, so they released him. So next time when you come somewhere, you don't trust, block your internet banking, so you can't pay ransomware for you, even if they point at you with the gun.
Okay, so I want to thank you. Thank you for the presentation. It was great. Thank you for being part of this meetup. I have a small present for you.
Thank you.
So hopefully you will join us again in the future.
Yeah, of course. Maybe with backendisti.
Okay, give it up for Peter.